Okay, here I am in Seattle, Washington, at the Pacific Northwest Seismic Network with Paul Gibbons, who is a seismologist who works here. Are you a student too?
I was a student at UW and got my degree in geology, and now I'm fully employed here.
Great, okay. And behind us you can see, well, go ahead.
This is what we call our wall of swarm, and these are 8 different stations. We're looking at 24 hours worth of seismic data. The top 4 stations here are on Washington's volcanoes. This is Mount Rainier, Mount St. Helens, and Glacier Peak. And we do see a nice local earthquake in the middle of the night last night.
Okay, so that's the red, is the earthquake?
Yep, those bright red signals mean a strong shaking. We can click on those signals and get a little bit more zoomed in view.
And does it tell you what the, how strong that is?
By using these stations in combination, we can triangulate a location and then, based on the amplitude of the seismic waves, calculate a magnitude from that.
And can you guess from that?
Let's see. I would say that's probably a magnitude 3 or so, somewhere in the network. I have not checked yet this morning. And we can check our website. PNSN.org is the main source for info in the Pacific Northwest. And it looks like we had an earthquake just east of Tacoma last night. So if we can click on our map here, we'll get all sorts of extra info once we zoom in on the map here.
Tacoma's just south of Seattle.
So magnitude 2.9.
So that's
So
what we
that
guessed.
was strong enough to be felt. And it was at 1:30 in the morning, so maybe not felt by everybody. We can look at the waveforms here. So these are the picked out waveforms from 10 or 12 of our 400 stations. And we use those in conjunction to determine the location and the magnitude.
So at your stations you have, we learned a little bit about those things.
Yeah, seismometers.
Okay.
So basically what this is, there's 3 parts to this. There's a magnet and a spring. The spring jiggles the mass on here, and the mass is actually copper coil. It's copper wire. It's spun around thousands and thousands of times. And anytime we move that magnet back and forth across the copper coil, we generate a small electronic signal with a positive and negative impulse.
Okay, and that's what the lines are.
I can show you a little bit more easily on our home-built seismometer here, where we've got the same parts. We've got our magnet, or pardon me, our copper coil and our magnet. And anytime we move that magnet back and forth across the copper coil, there's a small positive and negative wiggle on our needle. And so all we have to do is write down that signal, and you can see that as we move it back and forth. So we're creating a little bit of electromagnetic energy. And the wider the needle swing, or the higher the amplitude of the signal we get back, the larger that correlates to magnitude.
And there's something like that inside, well, that's this, right?
That's that, and that is in these blue instruments, our more sophisticated instruments, and we also have another example here, and you can see the springs are exposed on the outside of this instrument.
And where do you put these?
We have about 400 instruments deployed all over Washington and Oregon, and most of them are, well, it's a combination between the urban areas and rural areas. The ones that are out in the middle of nowhere are very quiet, and we can see very small earthquakes, but we also want to have some in the city to record strong earthquakes.
Is it you and me?
It must be.
I'm sorry.